be the meetings will be on YouTube. So if you miss a meeting, if you want to go back and watch the lesson again later, it would just be another resource for you. Okay, so if you click on that meeting, you'll see a bunch of, like, I have the date for every class meeting already typed in there. So all I'm going to do is link the videos to the different dates. So I hope that'll be helpful, especially if you miss a meeting and you want to see what the lesson was. Okay, we're still going to do practice quizzes and quizzes. But remember, the practice quizzes are worth 3 times a regular homework assignment. So a regular homework assignment is 10 points. A practice quiz is worth 30 because we really want you to do those. And then the quiz itself, remember, those are 100 points each. It's the biggest part of your grade. When you take that, you get 2 tries per question. If you get it wrong in the first try, you lose 50% of the grade. If you get it right in the second try, then you get 50%. If you get it wrong on both tries, you get 0. So you basically lose the half the points for each problem if you get it wrong the first time. And then, of course, there's a remediation you can do after every quiz. And this try we've set it up a little differently. You used to have to do the remediation and then tell us, and then we would blank out your first quiz and you'd retake it. This try, as soon as you finish the remediation, the retake quiz will be available to you. And then you take the retake quiz. And then once you've taken that, then you email us and say, hey, I retook the quiz. And then we'll go in and transfer your score over to the first quiz. So basically, you don't have to contact us until after you've taken the quiz, the retake, okay? Hopefully that makes things a little smoother for you and you don't have to wait for us to open the quiz up. You can just keep moving, bing, bing, bing through, okay? Also, in the grade book, we've been putting in 0s for homework that's not been turned in, but we've found that kids think, oh, that means I can't do it anymore. And that's not the case. So we're going to put M's in the grade book now. And M is going to stand for missing, okay? And when it's missing, that means that you can still do it. So hopefully that makes sense. When you do the assignment in Canvas, it'll automatically replace the missing with your score, okay? So that way too, I think your parents get a notice about missing work once in a while, and you can look at missing work. There's a button for that. So anyway, that's what we're doing. No more 0s. There'll just be an M for missing. It counts as a 0 in the grade book, but it's just a little different, okay? All right, I think that's all I got for the start of try 2, okay? I'm gonna present a screen to you now. It's actually gonna be my iPad for a short lesson today. And I have my chat open so you can ask questions as we go. Here it comes. You can zoom in on this so you can see a little better. We'll go through a short lesson on this, and then we're going to go to the whiteboards and just do a couple problems together. I know you guys have probably noticed that the meetings now are scheduled for 45 minutes long instead of 30. We're probably not going to use the 45 a lot of the time, but it's there just in case. So be sure you block that time off. Okay. Oh, one more thing I just remembered. I am going to be contacting kids and parent guardians when you miss online meetings. Some people got in the habit of starting to miss these a lot last trimester, and we just want to kind of nip that in the bud. So after today's meeting, the 5 or 6 kids that didn't show, I'm going to be emailing them and their parents and just letting them know that, hey, you missed it. We'd really like you to be here. I'll give you the link to the meeting, so if you want to watch it at that point, etc. But just trying to keep everybody on the same page with that people are showing up and stuff. Okay. All right. So here's the topic today is solving systems of equations. This is a kind of a fun topic in algebra. It's something every algebra kid learns how to do, and it's something that you'll see again in Algebra 2. But I even use it a little bit in AP Statistics, which is one of the other courses I teach. So this is going to be a part of your math career for a long time. So a system of linear equations contains 2 or more equations. The solution to a system of equations is the ordered pair that is a solution to both equations. Okay, so a system will always be denoted by this little brace here. Okay, and that just tells you that those 2 equations go together. And both of these equations are a line. Okay, if I graph these both on the same graph, they may cross somewhere. Okay, and that point where they cross is called the solution to the system. All right. So if you can imagine having an XY axis, and I graph one equation, and then I graph the other equation, and the solution is that point where they cross each other, all right? And that point is the one point that works in both of those equations. So once I solve the system, I'll have a point, x, y, and if I plug those into these two equations, you would see that that point is a solution to both of those equations, okay? Now, I'm going to erase this part because we're actually going to show you how that works here. So if you looked at the bottom, here it says the solution to the system of equations is the point 1, 3. We're going to verify that this is a solution to both equations. So 1, 3 is an xy, right? The first number is always x, the second number is always y. It's alphabetical order if you forget xy. So I could plug a 1 in for the x. So for this equation right here, it'd be y equals 2 times 1 plus 1. And then the y is a 3. So instead of y, I'm going to write a 3. So watch what happens. I would do 2 times 1 is 2. And 2 plus 1 is 3. So notice when I plug that point in and I solve the equation, I actually get a true statement. 3 does equal 3, that's true. So that 1, 3 is a solution to this top equation. Like, it works in the equation. On the bottom equation, I would plug a, whoops, had my eraser on. I would plug a 1 for the x. And I would plug in a 3 for the y. So I just wrote beneath that equation. And negative 3 times 1 is simply negative 3. And if I add negative 3 and 6, I would get 3. So again, that point, when I plug it in, makes that equation true. All right? So that's what we're going to be searching for, is that one point that makes both equations true. And there's 4 methods we're going to use to actually determine that point. Okay, and we'll get to that here in a second. So when we're solving systems, there are 3 possible outcomes. Okay, the first one is the picture on the left, and that's when the 2 lines cross. Okay, and I find the solution by just finding that point. And we will always make it cross at a spot where you can, find the point easily. Okay, like it'll always be at like one of these spots where like the point. What we're not going to do is make it cross at like here, where you have to guess, like, is it a half, is it a whatever. So like this picture, we're never going to do that to you. Okay, we'll always make it cross exactly at a point. In order for the equations to cross, they must have different slopes. Okay, so that's very important. The 2 lines, if they're going to cross and hit each other, the 2 slopes must be different. Okay, so if they have different slopes, that means they're going to cross at one spot, and I can find that spot. The second option is the second picture here. This is when the lines are parallel. So the 2 lines are never going to cross. When this is the case, we say that there is no solution to the system. Okay, there isn't a point that works in both equations. And we call them parallel lines. They have the same slope, but they have different y-intercepts. Okay, so they have the same slope, meaning, when you draw the triangle, those are the same, but they have different y-intercepts. Like the bottom y-intercept is -2, the top one's like 2.5. Okay, so same slope, different y-intercepts. The third option, far right picture, this one, the 2 lines are actually the same. You can't see the second line because it's on top of the first one. Okay, so in this situation, both equations are the same line. And we say, in that case, then there are infinitely many solutions. Meaning every single point that works on one of the lines works on the other 2. And obviously, these would have the same slope and the same y-intercept. okay? So different slopes give us lines that cross. So we have one solution. If I have the same slopes but different y-intercepts, those are parallel, and they'll have no solutions. And if the two lines are exactly the same equation, then we'll have infinite solutions. And on your homework, if it has one solution, you'll just type the point in with the parentheses. If it has no solutions or infinite solutions, there'll be a checkbox that you can click, okay? So every question will have those three things. It'll have a spot to write a point, it'll have a spot to click no solution, it'll have a slot to click infinite solutions, okay? So we're gonna be learning 4 methods for solving systems of equations. So basically, this is what we're studying until winter break, okay? 4 lessons, we'll do 2 lessons this week, 2 lessons next week, and then the 3rd week is the practice quiz and the quiz, okay? And then we're on winter break for 2 weeks. So this is what we're doing between now and next year, basically, right? So you're just gonna learn 4 methods for doing this. So just keep in mind as we do this, that everything we're doing between now and Christmas break is trying to find that one point where the lines cross. Or to say they're parallel, that there's no solution, or they're the same line and infinite, okay? So today, we're gonna be learning graphing. And that's the homework for Monday, Tuesday. For Thursday, Friday, we're gonna learn equal values method, which is a way to solve this using algebra. And then 3, substitution. That's another way to solve these using algebra. And then 4, elimination. That's another way to solve them using algebra. So these 3 are using some algebra and solving skills, okay? But they're all 3 approached a little differently. So today's graphing. So this should be a really good review of just graphing that we learned in first try. So the first thing I would do is graph the top equation. So remember, you start with the y-intercept plus 3, make a dot on the y-axis. And then the slope here is the -5/3, which tells us to go down 5, right 3. So there's our line. And you can connect them. And then I'm going to graph the bottom equation, where I'm going to start at -3, which is down here. Remember, that last number in the equation is the y-intercept, where the line crosses the y-axis. And then the slope on this one is up 1 over 3. So up 1 over 3. And notice it's going to hit a spot from that other line. Okay, so that spot where they cross, that is the solution. Now, when you type this in on Canvas, you have to type it in with the parentheses. Okay, so this point would be 3, -2. So that's how you'd enter that equation, or enter the solution, okay? You'd have to put in the parentheses, don't forget that. That is the only point that works in both of those equations, all right? So if you understand graphing, this is not hard. You're just gonna graph twice and then tell me where they cross. And I can see the chat, so if you have questions, let me know. Here's another one. A couple things on this one right off the bat. Notice the slope on the top equation is 4. That's not a fraction, but remember you can put that over 1 to make it a fraction, so that means you'd go up 4 over 1. The second equation has a -x, so that I don't see any numbers. So remember, you can put a 1 here next to the x, and you can put a 1 underneath the x, make it a fraction. So that one means down 1 over 1, okay? So let's do the top equation in green. I'm gonna make a dot at 3. That's the y-intercept. Then I'm going up 4 over 1. Now watch this one. 1, 2, 3. Jake, you have a meeting. You're late already. What are you doing? Sorry. Joys of at-home learning. Kid just late for his meeting. So up 4 over 1. Notice that went off the graph, okay? Well, instead of going up 4, right 1, it is okay to do the opposite. Go down 4, back 1. Down 4, back 1. Notice it still stays on that same pattern, okay? So I can still connect them, but that's what you do if it goes off the picture, okay? And obviously what I wouldn't do is, going up 4 over 1, I wouldn't go down 4 over 1 because that doesn't follow the same pattern. Remember, this has to make a straight line, right? So it has to follow that same original pattern. Now, bottom equation starts at -2 and goes down 1 over 1. But notice when I go that way, it doesn't cross the line. So instead of going down 1 over 1, I could go up 1, back 1, up 1, back 1. Again, I got to keep that same pattern because these all have to line up, right? So the solution to this one would be -1, -1, because that's where they cross. Remember, you got to type in those parentheses, okay? All right, so another one. Just a couple more, and then we'll try these together, and then we'll be done. So this one, y equals 2x plus 2 and y equals 2x minus 3. Hopefully you notice right off the bat, these two lines have the same slope, okay? When they have the same slope, there's two options. They're either going to be parallel and have no solution, or they're going to be the same equation and have infinite solutions. Well, I think you can see if you look, they're not going to be the same equation because they do have different y-intercepts. So this is going to be the situation where they're parallel. And we're going to end up saying no solution. Okay? But to get the full points on the problem, in your homework or on a quiz or test, you do have to actually graph the equations because that's part of this deal. So let's graph the top one first. Let's start at 2. Remember, if it's just a number, you can put it over 1. So I'd go up 2 over 1. There's my first line. And I'll change colors. Second line starts at -3 and also goes up 2 over 1. So you can see by the picture now, those are parallel. They're never going to touch. So we have no solution. And on the homework, you would just click no solution. Okay? All right, so let's do one more. And we'll try a couple of these on our own, and then we'll be done for today. So this one, let's graph them. Looks like they might have different slopes. Maybe. So top equation starts at 1, and I go up 2 over 4. There we go. Now I'll do the second one in blue. Start at 1, goes up 1 over 2. Rut-row. So those two lines sit right on top of one another. Therefore, we have infinite solutions. When you're spelling infinite, it's 3 I's. Infinite, okay? And they actually do have the same slope, right? This slope is 1/2. If you reduce 2/4, that's really 1/2. And the y-intercepts are the same. So they are exactly the same equations. So I have infinite solutions. So every point that works in one equation would work in the other. Okay, and that's the point of that. All right. So hopefully as you're doing these, you can tell right away how many solutions you're going to have. If you have different slopes, you're going to have one solution. Oops. I almost wrote 2. Sorry. You're going to have one solution. Okay. If you have the same slope, it's either going to be 0 or infinite. Okay. It's going to be infinite when they have the same y-intercept. And it's going to be 0 when they have a different y-intercept. Remember, those are the b's. So you can tell right away by looking at the problem how many solutions you're going to have. But we still like you to graph them because a part of this is we're practicing how to graph. Okay. All right. Now I'm going to stop this recording because we're not going to have the whiteboard activity in the recording. So how do I do this? Stop recording. Yay.